Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Lost City by Proxy 14. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 in every row, column, and 3x3 box once each. We also have Nurikabe, where we need to shade some cells so that all shaded cells excuse me, form one orthogonally connected area, and no 2x2 region is entirely shaded. Okay. Some cells, okay, so in a Nurikabe region, we have to shade some cells, and we cannot, and it has to be all orthogonally connected. One orthogonally connected region for this Nurikabe. So this, I guess, would be a valid Nurikabe region because we don't have a 2x2 region that's entirely shaded, and all the shaded cells form one orthogonally connected area, which means that you can go from any area in the shaded region and travel just by edges and get to any other cell in that shaded that's shaded. Right. Some cells have given clues in the form of letters, right? So we have an A, we have a B, C, D, E, F, where each unique letter corresponds to a different digit. So each of these digits are different. A is different from B, which is different from C, etc., etc. Clued cells are unshaded, and every orthogonally connected island of unshaded cells contains exactly one clue, the value of which represents the size of the island. Okay, so on a Nurikabe, again, so this can't be shaded, this can't be shaded, actually. This can't be shaded, so how do we go about shading? I guess we could do something like this. We could do something like that, right? Each of these cells, so clued cells are unshaded, and every orthogonally connected island of unshaded cells contains exactly one clue. So this is not valid here as a Nurikabe shape, because this island here would essentially have 4 clues in it, which when it's supposed to only have exactly one. The value of which represents the size of the island. And digits can't repeat in an island. Okay, so... Huh. Okay. I'm not sure how to go about this. Okay, so for one thing, I feel like Nurikabe, it's like the islands, do they have to touch the edge? Hold on. I'm going to pause this just to make sure I remember this exactly. Okay, so no, the islands do not actually have to touch the edge of the graph. They just have to be separated from each other. Can they be... Hold on, I'm gonna read the rule setting. Well, Okay, so for this island, if this were the island here, then D would be 5, since the clued cells represent the size of the island, and then digits cannot repeat on an island. So you could not have a 5 on this island here if this were this specifically an island, right? So that's the rule set for Nurikabe. We also have ambiguous cages, where cages aren't fully given, but instead their values are, which always must be in the top left, that is the leftmost cell of the highest point reached by the cage, corner of the cage. All cells of a cage must be in the same Nurikabe island. Okay. Okay. A cell cannot be claimed by multiple cages at once. Okay, right. So all the cells of a cage must be on the same Nurikabe island, right? And it must be the upper leftmost of the top row of a cage. And a cell can't be claimed by multiple cells at once, so you can only be part of one cage, which is the Nurikabe island. The size and composition of cages may be determined by the solver, or must be determined by the solver. Additionally, there are 4 types of cages in this puzzle. Cages with the same given value must be of different types. Oh. So here we have 4 cages, which are 10, right? Hold up. Clued cells are unshaded. Okay, so in this Nurikabe, you could have... Wait, why is there a 10 here and a 10 here? I'm confused. Contains exactly 1 clue. Wait, but I'm really confused now. Because it says clued cells are unshaded, and every orthogonally connected island of unshaded cells contains exactly 1 clue, the value of which represents the size of the island, and digits can't repeat on an island. So this has to be the same island, right? Cages aren't fully given, but instead their values are. Okay, so cages. Oh, okay, so even though... Okay, so you can have multiple cages on the same Nurikabe island. It's just that the Nurikabe island... Okay, right. The cages are not necessarily on different Nurikabe island. The cages could be part of the same Nurikabe island, and you could have multiple cages there. And in fact, you have to, because these two have to be unshaded, right? The size of the composition of the cages must be determined by the solver. Additionally, there are 4 types of cages in this puzzle, and cages of the same given value must be of a different type. So we have 4 cages that are 10 each. So one of them must be of each single type. And you have a killer cage, which is 1 type, which is digits in a killer cage sum to the value given in the top left corner. So for example, if this were the cage here, these 2 digits would have to add up to 10 if this was the killer cage. If it's a suspect cage, the sum of the digits in a suspect cage must be 1 away from the value given in the top left corner. So for example, if this were the suspect cage, it would have to add up to 9 or 11, right? Because that's 1 away from 10. A frame cage The sum of the digits in a frame cage must be 2 away from the value given in the top left corner. So these two digits would have to add up to 8 or 12 if it's framed. In an innocent cage, the sum of the digits in an innocent cage must be at least 10 away from the value given in the top left corner. And this would be then either 0 or less or 20 or more. And obviously would not be 2 digits then in that case. And those are all the rules. If you like to play along, there's going to be a link in the description. So remember, the cages can belong to the same Nurikabe island, but all the cells in a cage must be on the same Nurikabe island. Those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Well, actually, I'm going to go to the bathroom first. So we're going to pause for a little bit, and then I'm going to get started. So I'll be right back. Okay, I'm back. And we are going to start this puzzle. Let's go. Okay, so all the letters are essentially unshaded, right? All the unique clues are unshaded, and they're all on different islands. So these are all unshaded, and they're all on different islands. We also know the cages aren't fully given, and they are the top leftmost corner of the cage. And all cells of a cage must be on the same Nurikabe island. So they're also on islands for all these cells. So these are all islands. This is the top leftmost. And it has to be, well, it could be 2, right? This could be a cage by itself. We don't know. She should have, do we have 4 of each? Okay, so 10, we have 4 here. 12, we have 4 here. 20, we have 1, 2, 3, 4 here. And 24, we have 1, 2, and 3. So 24 is the only one that has 3. And remember, these islands are all orthogonally connected to each other. Or, sorry, to the same island. But they have to be different islands. And they can only contain one they can only contain one clue each. So this island is not connected to this one. So this can never be land. So this has to be the shaded cell, which is, we're going to make blue, which is essentially water, right? Same with this. If either of these are land, they would be shaded. So this has to be water. It has to connect, so it has to connect to there. Same here. This has to be water because it cannot connect here. It has to connect to the water somewhere, so it has to go that way. This could connect to here. That's fine. These cannot connect here, so this is water. This B. B is at least 2. A is at least 2. E is at least 2. So I think all of these are at least 2. Right? Yeah. Because these are both... Okay, so this is the top leftmost. This is... It could be just 2, actually, here. Or 1 digit of the cage. What else do we know? They have to... The water has to connect essentially to itself. Okay, so the 20 cages, one of them can be essentially whatever digit, like it could be single digit or multiple digits. But the other 3 have to be at least 3 in size because they can be at minimum 18. So A has to be at least 3 somewhere, right? Because either this one has to be 18 minimum or this one has to be 18 minimum or both, right? Could be 18 minimum. So A has to be at least 3. B, we don't know. Mm, hmm. So A has to be one of these 3 digits here, and it has to be one of these 3 digits here. Cannot be here, cannot be here. It's one of these 3 digits here. C has to be one of these 3. B can be one of these 4. One of these 4. Doesn't tell us much. Okay. Um, Interesting. So D has to be at least 4. It's connected to both of these orthogonally, so this is the same Nurikabe island. And one of them could be any digit from 2 or below or 22 or above. But the other one has to be at least 10. So this is, that would be 2 digits then. I guess it could be this one, and this could be 3 digits here. Okay, so D is 3 digits at least. Hmm. This is the same island. It must be either part of E or part of F. Okay, that's interesting. This cage cannot be part of E, right? Because if it were part of E, then the leftmost would be here, right? So this cage is, there is a boundary here on this cage. Oops. We want edges. So there is a boundary here. There's a boundary here. This we don't know about this cage. This we don't know either. This is the upper left, so it has to go there. Let's not make it black. I guess let's make it red. So it has to go here. This one has to go here. We don't know about this. This has to be this boundary, and it has its uppermost, right? So the upper left. So we always have that, I guess. And this one has to be a boundary here. So you always have that, you always have that. This is always there. Here, wow, okay, this is different. So this is a different cage here. We have a cage here. Oh, interesting. This is a cage here, this is a cage. This is a cage, which means that's a cage. Huh. Interesting. Okay. So this doesn't have to be a cage down. Well, okay, it cannot go down here. Oh. This cage here can never be 3. Because if it's 3, Right. This cage here can never be 3 because again, this is the oh, it could go this way. It's the top left of the it's the leftmost of the top row. So it could go something like this. But it cannot go down here is the point, right? So we don't know if this one is the innocent cage. The innocent cage is the least restrictive one, and therefore we want to figure out which one that is, right? Interesting. This is 22 also, right? It cannot be this is 2 at most. Okay. This cannot go this way because this is an island. Sorry, this is water. It cannot connect this way. You can't connect 3 this way. This has to be the innocent cage here because this is at most 2. It's 1 or 2. That means it's at most 17 in value. And the frame cage can only be 3 or more. Has to be 3 digits. Has to be, sorry. If it's not innocent, the value of the cage has to be 2 or less away from the given value. And since this is 20, that would be 18. But since it tries to, if it can't be 3 this way, it can't be 3 this way because it can't connect. Cannot go 3 this way because it can't be in the same island as this one because each island has its own clue. And this is part of the C island here. So this can be at most 2. Therefore, this is the innocent cage. All the other, because it can't be, it has to be 10 or more away from 20. Because if it's only 2 or 1 or exactly, that would be at minimum 18, and you would require 3 unique digits. And it can't get 3 unique digits because it can't go that way, can't go that way. So this has to have 3 unique digits, and it goes this way, at least. These then are islands, so it cannot go that way. So this goes this way, and we don't know. Okay, so this cage goes here to here to here. We don't know if it extends further. So all the 20s have to be size 3 or more. So it could go this way. We don't know if it goes more than that. These are boundaries of the cage. This 20 has to go this way then. And it could go either one of these. So this is all... it actually has to go this way. It cannot go this way. Because if it connects there, this Nurikabe Island would be the same as this Nurikabe Island. So this has to block here. It has to go this way then, and it's 3 in size. So this cage is there. This has to be, one of them has to be at least 2. So E is 7, 8, 7, 8, or 9 at least. So this is either 1 or it's 2 here. We're not sure which. This cannot connect here. So this is blocked here. This is a boundary. This is a boundary. Okay, so this is 3 in size here. It could be 4 or 5 at most. So the A has to be 3, 4, or 5. Right? Because it cannot connect this way. It could extend here, but it cannot connect all the way here. So this is 5 at most. So this is 3, 4, 5. How did I do that? That was weird. This is 3, 4, 5. This is 3, 4, 5. E again is 7, 8, or 9. B is at least 2. This is 2 at most here for this cage. This cage could go down here. This cage could go down here or go that way. Hmm. Hmm. We don't know which cage this is. We don't know which cage this is. One of them's innocent, one's suspect, one's frame. Sorry, one's frame, one's killer, one's suspect. The innocent one is here. This is at most 3. It could be, cannot be 4, because this cannot, this is the upper left, this is the leftmost of the top row, and so therefore this row cannot go up as a cage. So this could be a non-innocent cage here. This could be 4 at most. That's interesting. Can this ever connect to the 24 is kind of a question, right? So obviously it can't go that way. Can it go that way? If it goes that way, 1, 2, 3, 4, 5, 6, 7, 8, 9. As long as both of those are innocent cages, it's possible. Right? This would have to be innocent and this would have to be innocent. So it's possible. Oh, you don't even have it. You don't even have to have it innocent. These could be. Oh, so this is 6 through 9. Neat. It could be that one of these is suspect and one of these is framed, right? Oh, that's interesting. If one is suspect and one is framed, and this is 6, that would eliminate. That would have 6, 8, and 9 here. But the problem is this 3 digits would be at most 7, 5, and 4, which is 16, which is not enough to be framed. So this does have to be 7 or 8 or 9, right? Um. Hmm. 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 Okay. Hmm. Hmm. What is B at most? Hmm. Obviously, B can't be connected to C. What's the largest this could be? Hmm. The B cannot go all the way here because then these would both have to be water, but this is not orthogonally connected to that water. So even if it connected to here, I guess it could be 1, 2, 3, 4, 5. It cannot be go to here. 1, 2, 3, 4, 5, 6, 7. And then, well, no, that can't work because again, these would both have to be water. That would not be connected. So it'd be 1, 2, 3, 4, 5, 6, I think it could get to, right? And it could somehow get to like this, right? Could go here, then go around here, or go around like that. So I think B is 6 at most, right? Right, because the water can go all the way around here and then touch here. So B is 6 at most. Yeah, you could have 6 here. You cannot go to here. D could be quite big. D cannot go to here, though. If D goes to here, this water is separated from the other water. Oh, right. This is all land, so this has to connect that way. So this water has to connect here. Because otherwise it would be by itself if it didn't. If this was land, this would be cut off. This could go this way, something like that, to here. So this is part of DAFC or this A, right? We don't know which, because all the Nurikabe Islands have to have exactly one digit, right? One clue. Yeah. That's A, D, B, A. Um, this is part of B, F, or E. And if it's E, this would have to be 9. You could have 5, 6, 7 adding up. You could have an 8 here. And then... Oh. Can you have a single digit here twice? I think the answer to that is no. Okay, so this has to be land, right? Because if it's not land, if this is water, can it ever go that way? I don't think so, right? Because we tried 6 here, and we tried 2 unique digits here, which would have to be 8 and... If it's a unique digit, it's 1 digit, and it has to be 8 or 9. Because 10 or more away from 10 is 0, which is not possible, or 20 plus. And so if both of these are single digits, this would then be 6. One of these is 8, one of these is 9, and again, this would add up to at most 4, 5, and 7, which is 16, which is not possible to be a innocent cage since this is the innocent cage here. So because of that, one of these at least must be 2. Oh, so okay, this can't be part of this. If this is part of this, then the problem is that this will be an island. Sorry, this will be water area which is not connected to the rest of the water area. So this cannot be part of this. This has to be at least more. One of these digits is more, and if it goes this way and this is not part of the island, this water would not be connected to the rest of the water. So this must be island here. So this is 7 or 8. We know that for certain. It's either 7 in size, in which case this is 2 digits adding up. It cannot go to here, because then this would be too large of an island. Actually, it could go to 9. It could go to 9 as long... Wait, no, it cannot. If it tries to go to 9 here, the problem is this water is not connected here. So again, it has to be 7 or 8. So it's either 7 here or it's 8 here. And this can never be land. If this is land, again, it cuts off this part from being water. So this has to be water here, which means this is a boundary of the cage there. Oh, this is 3, 4, 5. What's the minimum digit here? If it's say you had 5 on this island. That means the others would have to add up to at least, what, 18? Sorry, the other two would have to add up to at least, yeah, 20 minus 2, which is 18. So the total would have to add up to 18 here, at least. That requires 4 and 9 here. So this is 4 through 9 in this area. And we know this is part of this cage, right? So 7 and 8 is not part of this cage because this is the leftmost of the top row. If this is 7, this is a single digit here. But this could add up to, again, 18 or 22 even, but it's unlikely to be 22. 18, 19, 20, 21, or 22, essentially. Oh, this has 3, 4, 5, 2. So this is 4 through 9 also here. Right? Still could be 3. 3, 8, 9 works. 3, 6, 9 works here as... or as a framed... Sorry, as a suspect or framed. But right, yeah. You have to have the most here to have the least here. This could go 4, 5 that way. And that would be fine. What else? So this must be part of F or B. Why does B have to be at least 3? Couldn't it be 2? Could be 2. Yeah, I don't know why I had... Yeah. It has to be at least 2 though, because this B is with this, right? Oh, wait. Say this was the innocent cage. Then this would have to be part of that island and be part of it, and therefore it'd be 3. Oh, okay, so this is, yeah, this is at least 3. Maybe that was the reasoning I had, right? So either this is innocent, you could only have one of these be innocent, right? And without it being innocent, one of them is 3. This 3 would have to conclude this, so this would be 4 at least. But this 3 could include here, right? So you could, that's why it's minimum 3 here. So this is, right, if this is minimum 3 here, then you have that area. And then this is minimum 3, which could be something like that. This can never go here. It could go here if the water goes to that area and then goes around here. So that's possible. So never mind. That's not. This could extend this way as long as it goes that, right? Wait, no. So if the C goes this way, the problem is this has to be water. Okay, so let's make that assumption. So C goes here. This has to be water. This is water because they can't be connected here. This then must go this way. This has to be at least 3, but it can't go this way. It can't go this way from here. And so this is blocked. So this can never go this way. So this is water. That's interesting. C is at least 2, right? Where can C get to, actually? This is 1, 2, 3, 4. I guess it can continue here. Okay, so 1, 2, 3, 4. 5 cannot connect there. 1, 2, 3, 4. 5 maybe. And cannot go this way, or this way. So C is 2 through 5. Okay. So could just connect to that. That's fine. Hmm. So these have to be, these 10s have to be killer, suspect, or framed. It cannot be innocent because innocent is 10 or more away from the value. And that would be then 0 or less, which is not possible for a cage, or 20 or more. So the 10 has to be 3 in size. Neither of these can be 3 in size. This cannot be 3 in size. No, this can't be. No, it could be 3 in size here. If it's 3 in size this way, this has to be what? Oh. If it's 3 in size this way, this would be what? Okay, so say this was 3 in size that way. The problem, okay, so this would have to be all water. This would be water. This would have to go this way, but then because this is not size 1, because this is at least 2, it has to go this way. But then that would block this area. So this cannot be 3 in size either. It's 2 in size or 1 in size here. This is 2, could go down 2 here, or 1 in size, or 2 here, or it's 1 in size. So this has to be the 3. So this is the innocent cage. This is the innocent cage, and this is the innocent cage. I guess we'll make those, I don't know, blue is innocent. Those are innocent. These cannot be innocent. This cannot be innocent. F could be part of this. or D is part of this. Could be part of many things. A, D, F, this A, or this C. 4, 5. Okay, cannot be part of this A because it's only 5, 3 to 5 at most. Hmm. Say this was part of here. This B could be... Yeah, it could be like that. Oh, wait, no. Could be like that. Well, like that. Or that. Hmm. Right. Okay. Hmm. This could be the innocent cage. In which case, then it could be 4 and 4. That's fine. Hmm. So this could be 8, and then this would be one of these could add up to 10, one of them could add up to 9, or one of them could add up to 8. Actually, would that work? I don't think that could work, right? If you have 8, actually, does 7 even work? If you have 8, this is at okay, no, you have 18 at minimum. Okay, that could work. So, okay, 7. If you have 7, what's the minimum these could be? It would be 8 and 9. So you have 7 here, 18 here, 8 and 9 here. What does that add up to? 8 and 9 add up to 17. Plus 7 is 24. 24 plus 18 is 42. So possibly... Okay, what would that be? 7, this would be 8 and 9 combination. You have no 1 and no 2 possible. This would add up to 18. So the rest of this would be 3, 6, 3, 5, 6, 3, 4, 5, 6, 8, and 9. This would add up to 18. This would be 8 and 9. Hmm. So this would be 18. Eight and 9. This would have to be innocent. This would be 10 then. Well, but okay, so one of them would be 8 or 9. You would have 3 and 6 or 4 and 5. Or 3 and 5. So that could work. Hmm. Huh. Yeah, that could work. So 7 does work fine that way. What about 8? 8 would be fine because you just exclude one single digit, right? Mm, yeah, that seems fine. 8. Okay, so hmm. The question is, what else can these be, right? So we know with 7, it has to be, this has to add up to 18, 8, and 9 in some order. Because that's the minimum. Or that's the maximum you can have for 7 digits already is achieved by that minimum. So you would have 7 plus 18 plus 8 plus 9 again. So 18 plus 8 is 26, plus 9 is 35, plus... Oh, wait, it's too big. I think I miscalculated, right? 18 plus 8 is 26, plus 9 is 35. 35 plus 7... Oh, no, it's 42. No, that's correct. I don't know why I was thinking it's 43. So that could work. Ooh. We know E, if this is 7, E has to be one of these 4 in this cage. We don't know which. Hmm. Hmm. I don't think D can be 3. If D is 3, I guess B could be like 6, and then A could be 5. F could be any large digit. Um, F could be a lot of things. So, what about the 12s? Oh, that's interesting. Okay, can F be... F could be 1 digit, though. If F is 1 digit, it has to be 2 here. Sorry, I'm thinking of this cage. If this 12 cage is innocent, it has to be 2 if it's a single cage digit, right? Because it's size 2. Therefore, it would be with 9. That's possible. So then these would all have to be water. This would have to connect to B, so it would have to go that way. Hmm. That seems possible. One of these would then be 10. So then this would be 8 in size, and this would have to go here. So this would go this way. This could be part of land. So this would be at minimum. Hold up. If it's 8, well, it could be 18. 8, 9. No, one of these has to be 9, so one of these is 10. So if this is 2, that means this is... So this is 2. This has to be 8 or 9. So let's just say it's 9. This would have to be 2 digits adding up to... Oh, yeah, yeah. 2 digits adding up to 8, 2 digits adding up to 10, 2 digits adding up to 18. So that's the minimum. What happens if it's 8, 18, 8, and 9? It should be fine, right? Because the missing digit would be 2. That seems like it'd be fine. What about this? 8. You have 8 and 10. 18. So 8 and 8 is 16. Plus 10 is 26. Plus 18 would be 44. Right, so then this would be without... 8 would be here. And 8 would be here. You'd have to have a 2. So this would not be 9 here. This would be what? 2, 3, 4, 5, 6, 7, 9. This would not be 2. So this would be 1. This could not be 9. 18 cannot be 3. It would have to be 5, 6, or 7 here as a combination, or something with 9 here. 9 could not be any of these, so this would have to be a 9. Adds up to 18 here, so it's another 9. So 2, 7, 3, 6, and 4, 5 all work that way. Adds up to 10 or 8. We don't know which. This would then be 1, 8, and 9 here. Obviously, that can be 9. This could not be 8 or 9. This could not be 8 or 9. Oh, wait, this could be more, right? Because it's not guaranteed 3. So that's, okay, so that's one thing we can do. We, E is one of those. We don't know what these are. These could be... This doesn't have to be 3 in size. This does have to be 3 in size for this cage. Hmm. Hmm. Huh. There's a lot of options. Hmm. I mean, it could... Hmm. Hmm. Okay. Hmm. Right, so we were thinking if this is 2, but that seems like it's fine? I don't know. Oh, can the A ever be here? If this is either, if it's a single digit, it's an innocent cage. But the A by itself could only be 3 at minimum, and that's not 10 or more away from 12. So I don't think A can ever be here. If this is A here, this is at maximum 4 and 5, which adds up to 9. So A can never be here. A does have to be one of these two then. Right? Because it can't be 3 or 4 or 5 there. Because by itself, it's more than it's greater than 2, which is 10 away from 12. And if you try to add it with 2, 3, 4, 5, you'll only get 9 at most, which is less than, well, sorry, it's less than 10, which is 2 away from 12. So it doesn't fit either scenario. So A has to be one of these two digits here. I don't know if that tells us anything, but hmm. So this could be a single digit here. It could be 2 digits, as long as it doesn't add, it adds up to 10 or less. Hmm. C could be 2 in size if A just goes down here, right? Because then you would have no 2 by 2 area. That's all water here. Just has to go down. Hmm. So this is an innocent cage. This is an innocent cage. We need to determine for 12 where the innocent cage is. So let's say this was 7. Okay, so then this has to extend either here or here. So that means F is at least 3. Hmm. Again, this adds up to 7, 8, 9. This becomes 3, 6, 8. 3, 4, 5, 6, 8, 9. Which means this is water. This has to be water then. That seems fine. This digit is also here. Uh, 18. We have 8 and 9. That seems okay. This is 8 and 9. This has to be 10. This doesn't have to be anything, really. Could even go 3 down here. Okay, that's not giving us any information. Okay. Hmm. Okay. Say, oh, that's interesting. Say A is 3. That means this would add up to, this has to be 3 in size, so this cannot be a legitimate 24 or 22 cage or 23 cage. So this would have to be the innocent cage, which forces this to be at least 3 digits. So it could be here, it could be here, so it would have to be 3. The B obviously would be 4, at least, because it connects here. So this would have to be water if that's the case. B would be at least 4. D would be at least 4. F, well, C could be 2, 4, 5. This has to connect this way because the water has to get somewhere. F could still technically be 2. This could go this way, so we don't know anything about that. It could just go here. Can this actually ever be 6 is kind of a question, right? I guess it would have to go this way. Okay, so that's an interesting assumption, too. What happens if B is 6? If B is 6, B has to be 6 here. This has to be all island. These would have to be islands, too. These would be islands. This would have to connect. So the F would have to be 2. That's interesting. This would have to be 8 or 9. Therefore, this cannot be 7. This would have to be 8, which would force that to be here, which would force that to be water. This has to go this way to be water to connect. This has to connect here. Oh, that's interesting. This has to connect here. This has to connect this way. A is at least 3, so it has to be here. And then we get a contradiction, because this would be 2. C would also be 2, and C and F have to be different. Because the water has to connect this way to connect all the way here. So B can never be 5. Sorry, can never be 6. B is 3, 4, 5. That's interesting. Well, can it ever actually go this way? So I'm curious that, yeah, if it goes this way, so this is not part of B. This is the only way you could have B be 3. Without it couldn't, actually, yeah. This is the only way B could be 3. How else would you connect it, right? Okay, so you can't have 6. We just showed that. If it goes this way, if it connects to here, it's at least 4. So to be just 3, it cannot go this way because that would block that off. So it would have to go this way, and this would be part of that cell. So this would be 3. This would have to be part of that. These would all be water. Interesting. So that it has to go... That's interesting. This would not work. Because this cage would have to have a 4 here, at least. But the problem is that this cage would then not be innocent, and it could not be framed or suspect because it's not 2 or less away from 12. So this doesn't work. So B is not 3. B has to be 4 or 5. Interesting. Okay. Well, since B is 4 or 5, I think it has to connect to this, then. Right? Without this, can it be 4 or 5? No, right? It would be stuck here. So this has to go to connect to here. And it could connect, it has to connect here. It could connect either of these ways. It could be there, potentially. So say it was there. Then I think, well, you could go this way, right? Okay, so this one is definitely land, and it goes this way. It cannot connect to here, so this is water. Interesting. This has to be water too. If it's land, the problem is that this would both be water to separate these islands, and that's not possible. So this has to be water also, and we don't know about that. We don't. Okay, this cage can only go this way because it can't. This is the leftmost of the top cell of the cage. So this is 4 or 5. This is 4 or 5. Could be something like that. That's possible. Could be something like that. Could go up still with it that. That's possible. That water. Can this ever be water here is kind of a question, right? Then this would be land. Obviously, this cage would not be a 24. So it'd be innocent, but we already have this being 3. Oh, then this would be 4 or 5, because this would have to be 3 at least. That's interesting. That would eliminate 4 and 5 here. This would have to be water. This could go that way. This would have to exit out this way. So we're trying... It's a lot of assumptions here. This would have to be 2, 3, or 6, 7, 8, 9. So this would be at least 3. Could be part of this. This is 2 or 3. Oh, this is 2, so this has to be at least 3. It cannot go 3 down here, so it either goes 3 here. It could go 3 that way. That is possible. So this would be 8 or 9 here. This would have to be 8 because the size of it, right? 18, 8, and 10. So this would be 9. 18, 8, and 10 with 8. 18, 8, and 10 is... So 8, 24, 44. So this would be 2. Again, this would be 2, 3, 4, 5, 6, 7, and 9. 9 obviously would not be any of these. This could not be... It could be 5, 6, 7 here. To add up to 18. Oh, but 9 could not be any of these. So this has to be 9 here. Okay, so this is 9. This cannot be 9 here. Or 8. It's 2, 3, 6, or 7. This would be 189 here. But obviously 9 could not be here. Oh, interesting. This would be 3. It cannot be just 3 digits here. This would have to be 4 digits to get a 24 without a 9 being here. Right? Because it cannot touch here for the C. So this has to be then 5. Which forces this to be 5. This is 5. B has to be 4 in this case. So this is water. A is 5. It has to be at least 4 here. It could be 4 like that. And this could still be 3. This would be 5, so it could connect. It cannot connect to this. Actually, yeah. Okay, that's one interesting aspect. I didn't think about that, but... Okay, so not making that assumption. A can never connect to this. This has to be 3 in size, no matter what. And A can only get 3, 4, or 5, right? So if it connects to this, this would be at least 1, 2, 3, 4, 5, 6, 7 in size, because this is an innocent cage, and it must be 10 or more away from 10. So it can't be 0, it'd have to be at least 20, and that's 3 digits. So this has to be water here. That means if A is larger, it has to go... If A is larger than 3, it has to go this way. So we were assuming this was water, right? If this was water, that forces this to be here. This is 4, 5. This one cannot be 7, 8, 9, or 6, 8, 9, or 5, 8, 9, or 6, 7, 9, adding up to 22. So this must be the innocent cage, which means this can't be innocent. So this is 4, 5. This is 4, 5. This is 4 or 5 here. This is 4, 5 here, which means this has to go here at minimum. This could be land, but then the problem is B doesn't have size 4. So say we made that water. A would have to go here. This water would have to go this way. A would have, well, okay, so that, okay. So this has to be water because this water has to be connected. Therefore, it must go there. The B cannot extend anymore, so B would have to be here. A would have to extend here, but then this water would not connect. So that does not work. So this has to be land here. We know that for certain. And we don't know if it's 4 or 5. This one specifically is problematic because it has to go all the way around here, right? So this is specifically problematic because it has to go here, that has to go here to connect. This has to obviously go here. This has to connect. This has to be connected. This must go all the way around. This then can't be more than whatever. This has to be 6 at least. Why doesn't this work? I don't remember. So far this can be 3. Oh, because this is 2 and the C has to be 2. Because this cannot go any more because it has to go down that way. That's the reasoning. Can it work that way? Well, these both have to be water. These have to be water. So this is similar here. That's water. But this connects, so you don't have to connect necessarily this one. So this could be land here. Well, this must connect this way, right? So you have to connect here. This is at most one land. And the F could connect this way. Right, so that is possible to be that way. Okay. So we know this is land here. We don't know if this cage cuts off here or if it's just a full 3 here. Hmm. What else do we have here? This is part of... Okay, can it ever be part of... It can be part of C. If it goes 3 that way and just those two, and then C is 5. So let's just see what what happens there. If this is 5, this is 5. So again, cannot touch any of these, so it would have to be this way, which means both of these are water. This has to be water going out that way. This water has to go out this way. This has to connect here. This cannot be... This has to be 4. This has to be 3. So that seems like it's fine. This is water. This must connect. This is water. This cannot be 3. This has to be 2. So this looks like it's fine. This is 3. This is water. It has to connect this way. This is 3. 4. This is 2. This has to be 9 then, because in this would then be 8. We'd have a 9 here. This has to go this way. This is 2, 3, 4, 5, 6, 7. 3 can't be here. 4 can't be here. 5 can't be here. This is 1, 8, 9. 9 obviously can't be here. This is... so this is 4. This cannot be 2, 3, 4, or 5. And it can't be 8. So it could be 6. This is 3. This has to be water because this is water. This has to connect this way. So this could be 6 this way. And in fact, so this would be 6 then. This would be water. This would be 4 that way. And that looks like it works. 24 could add up to 23, whatever. This 12. This would be the innocent. Ah, but then we'd have 2 innocents. So it's not possible that this can be 5. So then this can't connect to here, if that's the case. So I think that was the only way you could have 5 for the C, right? And actually, I don't think you can have 4 for the C either. Right? Yeah, the only way to get 5 is to connect here. You cannot, well, yeah. You could have 4, actually. 4 is possible. It would have to be like that and cannot connect to here. Right, so that was, it was interesting. It actually almost made it all the way to the end. The problem was that this had to be an innocent cage and this had to be an innocent cage. Right? Because this was 5. This was 5, and it has to be there. Right, the only way to get 5, you can't go down. You can't go down because those are different islands. So this is at most 4, and to get 5, you have to connect to here, and we tried that. So this cannot be 5. What about if it's 4? 4 could go here. So it could go 4 here. This is 4. This is obviously island. This is island. Ooh, this has to go this way then. So you have to connect to this. This has to go at least to here. This has to go at least here. This is island because it cannot be land. This has to be at least 3, and this is connected, so this has to go, could go here. It could go here. Or it could go here. This is 4, so this is 4. So this would have to go this way, which means it connects to here. This has to be at least 3, so it is 3. And connects here. This is 3, this is 3, this is island. So this has to be island 2. Then you have the same problem for that. That's 2. This has to be 3, so it has to connect here. That seems okay. No, but this is blocked then. So then this can never be 4 either. That's interesting. So this can't be 4 either. It's 2 or 3. This is 2 or 3. That's interesting. So say this was 2, right? So then we're going to try that again. These are all islands. This is 3. This is 3. This can't be 3. This is 4, 5. This is 4, 5. This is 4, 5. So this must go this way. And we could connect to either of these. This then cannot connect to here. It has to be 3 at least, but it cannot be part of A, cannot be part of this. So it has to go at least 3 here. It cannot go 3 here. Can't go 3 up. So it has to go at least, this is then part of land. And it cannot be part of this land, so this has to go that way. This has to be land because of that, so this is 5, which makes this island. This could be land or island, either one. This has to be island to connect to here, which forces this to go that way around here. This has to connect to that. This must... Ooh. This is by island by itself, because these can't connect. And then this doesn't have a clue. So this can never be 2, is what we're saying. Okay. That's interesting. So this is at least 3. Huh. This can never go this way anymore. This can never... I mean, it could go down here, so this doesn't necessarily have to be... So say this is not part of F. That's what we're sort of trying to figure out. If this is not part of F, it goes this way, right? It has to be part of D then. So it has to either connect to here or here. So here or here. So it connects to D. Then this has to, okay, so these are separate. This must connect to D, so it blocks here. Either here or here. So it has to connect this way, which means it connects this way, which means it connects through here. So that would force... Okay. So we're trying to make it not part of F. So I guess it could go this way. Well, F, we know it cannot be just 2. Guess it could go like that, maybe? A would be 3 then. So this would be 3, this would be 2. That seems fine. F could not be 3. So F has to be at least 4. Well, but B is 4. I guess B could be 5 technically, but F... Okay, so I think what we've shown then is this has to be part of F. And it cannot be part of D. Right? If we tried to make it part of F, if we tried to not make it part of F, can't be part of C, can't be part of this A, can't be part of this A, it has to be part of this D. And if it's part of this D, this gets blocked this way. This has to go at least 3 because it's the innocent cage. So it has to go down here. That blocks off this, which goes off here to here to here. And then F doesn't have a number. So this has to be part of F. Therefore, it will block off this way. So since that's the case, it has to go here. So it has to connect... This will block off this, but we don't know. So this is part of F. Could be part of that way. It could go some weird thing like, well, it can't be there. So to connect, it could connect this way, technically. Can this be blocked? If this is land, then these waters do not connect to this. So no, this has to be water then. This can no longer be 9, right? What's the size this can be most? This could go down here, and it could be water here. That's possible. So this is at least connected to here. This is at least 5. Okay. What can this be? Can it ever be 9? No, probably not. 1, 2, 3, 4, 5, 6, 7, 8, 9? But then this is 3 at most, which is not possible. So it cannot be 9. Can it be 8? Well, okay. What happens if it's this? 1, 2, 3, 4. Okay, so these would have to be water next to each other. This would have to go down that way. This connects here, but this needs a way to connect, so it would have to connect here. This would then connect here. It seems possible. This is 4. Connects this way. This has to connect this way, so it has to go here. It has to connect to here. So this is water. A is 3. This is 3. This is 3. Which makes C2. So this has to be water. This seems feasible. So if this is 8, then this is 7. So this is water. This is 4 each. So this is 4. That means these are water. This doesn't connect except through here. So this is 5. That's interesting. This is a 3 cage here. And since this is a 3 cage here, that fails. But that was a long way to show that this cannot be 8. That's, I don't like that. But this can't be 8. That's pretty long-winded. Oh, this is 5, 6, 7, 8, 9. So this must continue this way, because it cannot be an innocent cage of size 1. So this has to go this way. Therefore, this is water. This has to be at least 3. So it either goes 1, 2, 3, 1, 2, 3, or 1, 2, 3. That's pretty broad. So this is at least 2, which means this is 6, 7, 8, or 9. Oh, but it can't be 6. If it's 6 here, these two... Oh, no, it could be. Because it could be framed or suspect. So we know this goes this way and then goes this way. Could go down. We don't know. This connects here. Could connect that way. That's interesting. So it has to be 3. Connect. So it either is part of this or part of this. So if it blocks, what happens if it blocks this way? Well, but this can continue through. We don't know, yeah. So say if it blocks that, then this has to be water. This is water. Hmm. Hmm. Can the sea ever be 3 is kind of a good question too, right? That means this is not 3, this is not 3, this is not 3. So we have 4, 5, 4, 5. This is not 3, 4, 5. It has to be 6 or 7 here. So we have 4, 5, 4, 5. This must be part of the island. And it could extend to here. We just don't know. This has to go here. But this waterway must connect. So it has to go here. This has to be island. This has to be island. This water still must connect. This can no longer be island because these are separate islands. And this would be 4. And this would be size 4, but they're different digits. So no, C always has to be 2. We've just shown that then. I think that actually shows that this can't be 3 either. Right? So I think 8 has to be 3. So say this wasn't a 3. Say this wasn't 3. This wasn't 3. This is not 3. It has to go this way. It has to go this way. The problem is this water needs a clear exit. It has to go this way. This land still has to be 4 at least. It goes that way. But then this is water, and this is water, and they're both 4. Yeah, so A has to be 3. That's what we've shown. So A is 3. A is 3. This is 3. That's 3 in the corner. Therefore, this is not part of land. So that's the full there. This is water. It must connect to the other waters, so it connects that way. This can't be 3 here. This can't be 3. This is 2. This is 2. So these are waters. And this must be water, and this must be water. So this is the innocent cage, and it can be any digit. This has to be 3. This is 2. This is size 3, so this has to be the innocent cage also. So it's either this way or this way. If it's this way, there's no island to get to here. So can this ever be, if this is land, the land cannot get to here. So if this is land, this would be water, water, water. So this can't be land. This is then water. If this is land, same problem. This is water, water. So this can't be land. This is water. If this is land, this is water, water. That's not possible, so this can't be land. So this has to be the land here to form the non-2x2 area that's shaded. So this is done here. So this must have at least 3. This is the full cage, then has to be here. We know there's a 9 here. There has to be a 9 here, so this cannot be 9. This could be 8. Yeah. This has to connect, so this has to go this way. This could extend here, so this is still fine. So this is 2, this is 8, one of these is 3, we're not sure which. Can this ever be 9? 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe. This cannot connect to here anymore. So this is at least 4. So if it goes 4 here, this would be water, water, and it can be here at most. It could be 4 here, and then this could be 1, 2, 3, 4, 5, 6, 7, maybe. Okay. We don't know where the innocent cage is. So this must be at least 4, because if it includes this as a cage, then it would be 4 plus 3 other digits, because you can't have 2 digits adding up to 22 minus 4, which is 18. I guess it could be 5. This could be 5 and 3 digits. That's possible. Okay. This is any digit here. These two just have to add up to less than 14, which is Oh, 3 cannot be here because it's on the same island. So this has to be 3 here. Again, this has to add up to 14 or less for these two digits. These 3 add up to 22 at least, so the 9 has to be there. This could still be 8. These add up to 18 at least, so that means this is 15 at least. So this is 15 at least. So 6, 7, 8, 9, 6, 7, 8, 9. Three cannot be here and cannot be here. Two cannot be here. This must add up to at most 14. So this is 8 at most here. Cannot be 3. Could be down to 1 because these two could add up to 10. Okay, so those are the possibilities. That's a lot. This must add up to at least 20. Oh, that's interesting. This can be any single digit, so that's fine. One of these is a 2. That's what C is. 3 has to be one of these 3. Hmm. What happens if this is 12 here? Then this becomes island. This has to go down here, and then we don't know if it closes off that or that. Well, this one has to connect, so it has to go there, and then it has to connect here then for these 3. That still seems fine. It connects here. It would have to connect to here. And that seems fine. This would be a single digit, which would force that to be 8. That's interesting. That seems fine, though. This would not have an 8. Oh. But, right, then we'd have a problem. This can never be 8. Because if this is 8, that means this has to be... We know a 9 has to be one of these. 9 cannot be here. Because this one of these is 8 and 10. Actually, I think it's... What is it? It wasn't that. The issue is more... Can this ever be a singleton now? So if this is 9 or 8, this has to be at least 8 and 10. So 8 and 10 plus 18. 8 plus 10 plus 18, that's 26 plus 10 is 36. 36 plus 7 would be 43. And therefore, you'd have to have two digits losing. You'd have to lose two digits to get to that would add up to 2 at most. And they're both unique, so that doesn't work. Or if you have 8 digits with 8, 10, that would require 1 and 9 to be... Okay, so that... So again, this is 9. That makes this 8. 9 cannot be here. This would have to be 8 and 10 added together, but without a 1. So this would be 8 and 10. 9 could not be here. 9 would have to be here, which would force this to be 6, 7. So, okay. This has to be then this way. Because we've just shown that that doesn't work if this is a single digit. So this must be a non-single digit. So it has to continue here. This then is water, water. This is 4, size 4. This is 4, which means this can't be 4. This is 5, 6, or 7. And the reasoning was because 9 could not be here. 9 could not be any of these. We need a 9 on this island. It has to be here. But then that forces this to be 6 and 7, which is not possible then. Because 3, 6, and 7 would add up to 16 at most. And that doesn't work. That's the reasoning for that. Okay. So this is at least 7 then, right? Because this is 3 for this cage. This is 4 with a 9 being here. Oh yeah, 9 has to be here, so this couldn't be 9 anyways, and can't be a single digit. If it's 8, and this is 9, 10, this would be 18 at minimum, 9 and 10. 18 plus 9 plus 10 would be 37. 37 plus 7 would be 44, and that would be 2 digits that are excluded, which would have to add up to 1, which is not possible. If you have 8, that's 45, and therefore 1 digit excluded, which adds up to 0, which doesn't work. That's the reasoning for that, for the 9 not being here. Also, 9 has to be here, too. We know that for certain. This is 4. It could be that's not part of the cage. It's likely part of the cage, though. If it's not part of the cage, you could still have 1, 8, 9, right? Because it could add up to 22. So this is 5 through 9 here. And we know the 9 is here. Can this actually be 7, 8, 9? I guess if this is like 3, 6. Yeah, that's possible, I guess. 3 cannot be here, 3 cannot be here. 3 has to be one of these 3, and then 3 has to be one of those 3 then. Okay, 3 cannot be here, so 3 is one of these 2 then. Can you ever have 3 not be on this island? If you have 7, no, right? 3 always has to be on this island. If you have 8, maybe? 8 plus 18 plus 8 and 9. 8 plus 18 plus 8 is 34, plus 9 is 42. Yes, so you could have 3 outside. Okay. Interesting. We don't know where the framed or the suspect cages are. Okay, this is at most 14. So this is then at this has to be 6 at most, right? If you had 7, that would be 7 and 8. That would add up to 15, and that doesn't work. And we know it's 2 digits here. This cannot have a 9. It cannot have 4. This is at least 5. Hmm. Hmm. Can this go this way? Is kind of a question, right? That means no, it cannot. It has to. Okay, so yeah. This is right. So this is blocked here. This can only connect this way. So this has to connect here. This has to connect here then. So this must connect this way through here because this has to be 2 in size. This could be 3 that way. So this is 7 or 8. This is also 7 or 8. So these are both a 7-8 pair here. Interesting. This is at least 3. Could be 3 here, could be 3 here, could be 4. We don't know, right? This can't be 7 then. It's 5 or 6. Could be 5 this way. Okay, so this is a cage by itself, and therefore it's innocent because it cannot be framed, suspect, or killer. So this is 1 or 2 here. This cannot be. So this has to be frame, suspect, or innocent, or killer. And it cannot be killer because it would have to be 2 and 10 adding up to 12. Can't be frame because it cannot have a 9, so it can't be 2 and 9. This has to be 2 and 8 then. So this is the framed cell. Killer's red. We'll mark in red. Framed will be yellow. Suspect will be... Okay, so this cannot be 8. This must then be 6, 7, and 9. Because that's the only possibility. So this is also framed because it's 2 away. This has to be at least 1 away or 0 away. So this is killer here. Same here. This is framed or killer. Sorry, suspect or killer. This is framed. This is framed. This is innocent. This is suspect or killer. We're not sure which. This is 6, 7, 9. What are the remaining digits in the row? We have what? 1, 1, 4, 1, 3, 4, 5. So this is 1, 4, 5 here. This is 1, 3, 4, 5. 3, 4, 5. Okay. This has to add up to 8, 9, or 8, 9, 10, 11, or 12. Cannot add up to 0 or less. It cannot add up to 20 or more. So 8, 9, 10, 11. Okay, so the remaining digits in box 8 are 1, 2, 3, 5, and 8. These can't be 3. 1 works with 8. 2 works with 8. 3 works with 5 or 8. And 5 and 8 cannot be together here. This is not, this is either adds up to 11, 12, or 13 here. 1 does not work with 7 or 8. 2 does not work with 7 or 8. 4 could work with 7 or 8. 5 could work with 7. And 6 could work with... No, 5 could work with 7 or 8 also. 6 could work with 7 or 8. Huh. 5 actually would have to work with 7 specifically. Hmm. Hmm. This can't be 4 here because of this 4. This can't be 3, obviously, because of that 3. Um... This must add up to at least 20. I think we have to have a 9, right? 20 plus this can't be framed anymore. It's suspect at minimum. So that's 11 at minimum. This could be framed. It can't be innocent. So this is 8 at least. 8 plus 11 is 39. 8 plus 11 plus 20 is at least 39. So the 9 definitely has to be in this cage here. If it's 7, you could have 5, 6, and 9 with this cage, and that would be fine. Okay, can this always has to have a 9, right? If this is not 9, what's the minimum this has to be? 6 and 8. 3, 6, and 8. Sorry, the maximum this could be. It's 3, 6, and 8 because 7 and 8 can't be there because that would eliminate all possibilities here. So 6, 3, 6, and 8 adds up to 17, which is 3 away from the actual value. So it can't be framed. It can't be innocent, suspect, or anything. So 9 does have to be one of those two, which means this can't be 9. That means 9 is here, and then 9 has to be one of those two. Okay. This could be 3, 7, 8 here, possibly. This can't be 8, actually. Because of this 8. Three is one of these 3 here. 3 could be any of these. Hmm. Hmm. Oh, this 12 is the innocent. So we have all the innocents shown. These are the frame, 12 and 24. Um, hmm. Interesting. Okay. Wait, can this ever be 8? I don't think so, right? If this is 8, this would be 9 and 10 at least. So you have 9 and 10, 19 plus 18. That would be 37, and then you have the same problem. 37 plus 7 would be 44, but you have 2 extra digits that you lose. And so those 2 extra digits would have to add up to 1, which is not possible. If you have 37 plus 8, right, so this can never add up to 8. So this cannot be the framed one. It has to be either the suspect or the killer. And so because of that, 5 can never be here. 8 has to be here, right? It can't be 3 and 5 adding up. This has to be 8 with 1, 2, or 3 here. So this has to be 8 here, which means 8 cannot be here. Since 8 is here, 8 cannot be anywhere else on the island. This can't be 8. This is 7, which forces this to be 8. Therefore, this is 3 digits adding up to 20 at least. And you cannot have 7 or 8. It has to be 5, 6, and 9 to add up to 20. So this is 5, 6, and 9. That eliminates 5, 6, and 9 in the rest of the island. This can't be 5 or 6. This is 4. So this is a suspect, which we'll mark as orange, 12. This must then be the killer. So this has to be the killer here. That's the killer 12. This is the orange and the yellow look very similar. I don't know, pink? Maybe we make it pink. The yellow is framed, the pink is the suspect, the killer is the red. So this is 4 and 7. We have 5, 6, and 9 also here. This is 8, so this must be part of the island. So this has to go... Well, we don't know if these are cages here. This still could be 8 and 9 here for these cage values, right? Three has to be one of these. These cannot have 8. Okay, so this, what are the remaining digits in row? Okay, so this can't be 8. So this cannot be the killer, 20. It has to be either the suspect with 6, 9, or the frame, sorry, that would be frame with 6, 9 to add up to 18, or the suspect with 7, 9. One of these is land, one of these is island. Oh, this one has to be land because we have a 2x2 area where 3 of the digits are island. So this has to be land, which forces this to be island. This must be the 9 because that's the only place for it. So this can't be 9. This has to be a 5, 6 pair adding up to 20 at least, which the innocent cage is. That eliminates 5 and 6 from the rest of the innocent cage, or the rest of the row. That leaves this as a 7, 9 pair, and therefore this is the suspect cage. Right? It adds up to 19, which is 1 away from 20. This 20 cage, I don't think can ever be 20, right? If it's 20, you have 8 and 9 at minimum here. Yeah, 8 plus 8 plus 9 is 25. Plus 20 would be 45 for 8 digits, 8 unique digits, and that's not possible. So this must be not killer. This has to be then the framed cage. So this has to be the killer cage here, which forces this to be 8 and 9 to add up to 20. So this is 8. This is 9. 9 cannot be here anymore. Where's the 9 in row 6? It has to be there. Remaining digits in row 4, we have 1, 4, and 8. This can't be 4 because of this 4. This is 1, 4, and 8. 1, 4, and 8, but cannot be 8 here because of that 8. Rest of the digits in row 6 are 1, 2, 5, and 6. This can't be 2. This can't be 5 or 6 because of the 5, 6 pair in the box. Okay. Rest of digits in column 8 are 1, 4, 5, 6, 7. But this can't be 4 because one of these two is 4 here. 4, 5, 6, 7. 1, 4, 5, 6, 7. Pretty broad still. So this is 18. This is 8. That's 26. You could have 8 and 9 here, which adds up to 17. That would mean 8 and 9? No, hold up. 26. That's 43. So 3 does have to be here no matter what. Right? You can only have 1 and 2 outside. Because 18 plus 8, we know this is 8 now because this is 7. Because 8 has to be one of those two. So since 8's one of those two, 8 cannot be here. 8 has to be here. So that's the E. Because 8 cannot be here. 8 can't be here. 8 can't be on the island. So this is 8. I'm not sure. I think 3 always has to be here then. Right? 18 plus at minimum 8 and 9. So that's 35 plus 8 is 42. So it's 1 or 2 is outside. So this can't be... Okay, 1 or 2 is outside. That means we have to have a 4 and a 5 inside. And a 3. So this is 3. This has to be 4 and 5 on the inside because 4 and 5 cannot be here. Actually, 5 could be here. 4 cannot be here. Sorry, 4 has to be one of these cells. So this can't be 3 or 4. This digit is whatever this digit is. Or it could be... Yeah, so 9 has to be one of these. 3 can be... it could be either 8, 9, or 10. So this is 5, 6, or 7. 5, 6, or 7. I mean, technically it could be 12, but that's too big. 12 plus 9, which would be 21, plus 8 is 29, plus 18, yeah, it's too big. So it has to be 5, 6, or 7 here. E... Yeah, E has to be here. That's 8. This can't be 7 anymore. This can't be 9. We have a 5, 6, 5, 6 pair in column 2, which eliminates 5 and 6 in the rest of the column. This can't be 5. This can't be 6. This is 7, which means this can't be 7. This can't be 5 or 6. It's 1, 2, 3, 8. 1, 2, 3, 8. 1, 2, 3, 8. Okay. If this were 2 digits, Okay, this can't be 3. So if this were 2 digits, the problem is 1 and 2 can't be with 2 digits to add up to 12. 8 would have to be with 4, but 4 is already here, so this couldn't be 8. So this has to be 3 cells in this cage. Because it can't go down, because then this would be 8, whatever, right? It could be 4, so we don't actually know if it extends this way. It could be 3 this way, actually, so we don't even know if it extends this way. Ugh. There's a lot of possibilities here, so we don't know if it extends that way. It goes down, though. We know that for certain. We just don't know if it extends there, or if it extends here, or if it extends both ways. Could potentially extend both ways. We have a 1-2, 1-2 pair in column 6, which eliminates 1 and 2 in the rest of the column. So this can't be 1 or 2. What do we have then? This can't be 1 or 2. This is 3 or 8 here. 3 or 5, 6 or 9. Remaining digits here. No 1, 2, 4. So 7 has to be one of these two. So it's 3, 5, 6, 7, 8, 9. 3, 5, 6, 7, 8, 9. 7 is one of these digits here. This cage is done, so we know it's this cage. This is a cage, this cage, this cage, this cage. This cannot be 9. It could be 1 or 2, or 5 or 6, because it's whatever this digit is, could be. Or it's 1 or 2 outside. The 8 is already out. The rest are in, as long as it's 3 through 9. One of these is 8. This has to be either, again, a suspect or a killer here for this 10. This is suspect or killer. This must then be 8 and 9 or 8 and 10. 8 and 9 with 18. So that's 34 plus 9, so that would be 2 outside. Or 8, 10, 26 with 18 is 44, so that's 1 outside. You have 5, 6, 7. Oof. You could have 3 digits here, 7, 8, 9, possibly. These digits are 1, 2, 4, 5, 6, 7. This is 1, 4, 5, 6, 7. Could be 5 here and 4 here. That seems fine. These digits are 1, 2, 4, 5, 6. We know 4 cannot be here. 4 is one of these 2 digits here. This is 1, 2, 3, 8. There's possibilities. That could be here, here. 8 has to be one of these 2. That doesn't tell us very much. This can never be 8. If this were 8, again, it has to be killer. So it has to be with this one at least. Cannot be with this. Has to at least be with this or that, or these two, or these three. So this can never be 8. We have a 1, 2, 1, 2 pair, which eliminates 1 and 2 in the rest of column 5. This can't be 1 or 2. This can't be 1 or 2. This is 3 or 8. Hmm. 3 is one of these two here. Rest of column 1 has to be 1, 2, 5, 6, 7, 8, 9. No, 8. 1, 2, 5, 6, 7, 9. Okay. This adds up to 18. There's no 8 there, so 1 cannot be any of these digits here. Right? This adds up to 18 this adds up to 18. 1 would require an 8 and a 9, and we can't have an 8, so this can't be 1. This could be 2 with 9, or 2, 5, 6, 7. Sorry, 5, 6, 7 is a possibility. 4, 6, 8 doesn't work. 4, 5, 9 does work. Okay, so 2 can be with 7 and 9, so this would be 2, 7, 9, 7, 9. It has to be with 7 and 9, so that's the case. 9 has to be one of these two digits here. 5 means these add up to 13. 18 minus 5 is 13. No 5, 8, obviously. It could be 6, 7. And 4, 9 is possible. If this is 4 and that's 9. Okay, so 2 cannot be here. So if it's 2, you have 7, 9. If it's 5, it's either 4, 9, or it's 6, 7 here. If it's 6 here, these add up to 12. So it cannot be 3, 9. It can't be 4, 8. It could be 5, 7. So it could be 5 and 7 here. Oh, this can't be 5, 6, 7. So, right, so 6 doesn't work. 6 requires this to be 3, 9 for 12, but the 3 is impossible. Can't be 4, 8 because the 8's already accounted for. And the 5, 7 would eliminate all possibilities for that cell. So this is 2 or 5. If it's 2, it has to be with 7, 9. If it's 5, these two then would add up to 13. So it's 4, 9, or 6, 7. But it can't be 6, 7 because then 5, 6, 7 there, and that would eliminate all possibilities for that cell. So this has to have a 9 here. So this is 9 here guaranteed, which means this can't be 9. Therefore, the 9 in column 7 has to be here. So it's 2 with 7, 9, or 5 with 4, 9. Either way, 9 has to be here. Okay, so that means this can never be 6 here, because one of these digits is the 1 or 2. The other one is that digit there, which could be 2 or 5 only. This is a 7, 9, 7, 9 pair in column 1, which eliminates 7, 9 in the rest of the column. This can't be 7. This can't be 7 or 9. This can't be 7 or 9. Therefore, this cannot be 3 unique digits being the cage here. Well, it could be if it's 5, 6. It could be, no, it could be, yeah, it could be 5, 8, 9. It could be, sorry, 6, 8, 9 here. Because we have the framed cage for 24. We have this is either suspect or killer. So it could be 6, 8, 9 still. 6, 8, 9. That's possible. Okay. In this box, we have a 1, 2, 1, 2 pair here. So this cannot be 4 digits adding up to 12. Because 4 digits adding up to 12 is either 1, 2, 3, 6 or 1, 2, 4, 5. And since this is a 1, 2, 1, 2 pair, that means only one of these could be 1 or 2. So it must be 3 digits adding up to 12. So the possibilities are 1, 3, 8, but it has to have a 5 or 6. So 1, 3, 8's out, 1, 4, 7's out. Could be 1, 5, 6. 2, 3, 7's out. 2, 4, 6 works, and 2, 5, 5 does not work. I think it has to be 1 then. Right? 1, 1, 5, 6 works, but 2 would have to be either 5, 5 or 4, 6. And neither of that, this can't be 2, 4, 6 this way. This can't be 2, 4, 6 here. So neither of these can be 2. Therefore, this is 1, which makes this 2. This 1 eliminates 1 here. So that's 2. This 2 eliminates 2 here. So that's 1, which means this can't be 1. This can't be 1. This can't be 1. So 1 has to be one of these digits here. 2 then has to be one of those 2 digits here, which means this can never be 2. This 1 eliminates 1 here, so this is 8. That eliminates 8 here, so this is 3, this is 2. This 3 eliminates 3 here, so this is 5, which means this can't be 2 or 5, this is 1. This cannot be 1 or 2, this is a 3, 8 pair, which is a suspect cage. So this must be a killer cage and a framed cage. Well, this can't be killer, so this must be framed. And this must then be a killer cage. And therefore, this is 3 and 5 adding up to 10. 5 cannot be here, here, or here. This must add up to 10. So we have 8, 10, 18, and 8. That's 44. So the 2 cannot be within this island because it adds up to 44. So this is, ooh, except that doesn't work. This 5 eliminates 5 here. That's 2, 7, 9. This then has to be 2. This is 1. This has to be 4 and 6. Does that work? 18 plus 8 plus 8. Plus 10. Oh, it's 44. Right. You lose the 1. My apologies. So this 2, right. This can't be 1. This is 2. So 2 is one of those 2. Okay, yeah, that works. This can't be 5 or 7. This has to be a 1, 4, 6 triplet here, remaining. That makes this a 7. This 1, 4, 6. This 1 and 4 eliminate 1 and 4 here, so this has to be 5, which means none of these can be 5. The 7 eliminates 7 here. We have 1, 4, 5, and 6 remaining here, but this can't be 4 or 1 because of the 1 and 4 in the row. This can't be 8 anymore. We have a 1, 4, 1, 4 pair in box 6, which eliminates 1 and 4 in the rest of the box. Therefore, this has to be 8 here. This is a 5, 6, 5, 6 pair in box 6, which eliminates all the 5 and 6 in box 6. So this must be 7. That eliminates 7 here and here. Okay. So this is killer. Okay, so this is a full cage. This is a full cage. This is 11. 3, 8, 4, 7. This is killer. We don't know what this is. It could be suspect or killer. It cannot be 1 because of the 1 here. Therefore, it's 2 and 6. This is 1 with 5 and 6 here, which eliminates 5 and 6 in the rest of the possible cells. Oh, this can't be 3 because of this 3. So this can no longer be 5 or 6. This can no longer be 5 or 6. So it's 3, 4, 7, 8, and 9. Can't be 8 because of this 8. This 8 eliminates 8 here, so this is 3. This is 8. That eliminates 8 here, so this is 3. This can't be 3, this can't be 3, and this can't be 3. Where is the 3 in column 3? It has to be here. This 5 eliminates 5 here, so this is 6, this is 5. That eliminates 5 here, so that's 6. This can't be 5 or 6, so cannot be part of the cage. So the cage has to go here. And therefore, this is 5. This is 5. It's green. This can't be 7. So this is 4, 6, and 9 here. 7 has to be one of these two. This is 5 and 6. This can't be 4, 2, or 6. That leaves this as a 1, 7 pair here. This is 1 or 7. This 4 eliminates 4 here. Where's the 4 in box 4? It has to be here, so this is 4. This 6 eliminates that 6. So this is specifically 1 or 7. This is an island. It can extend. If this island... Okay, so this is 6. If the island extended here, this would not be 4, because it would only be up to there. And in fact, actually, this island is 6. Since this island is 6, it cannot... If we try to extend here or extend here, the problem is this would be 3 in size for this island, so that wouldn't work. So this has to be the full island here. This is the cage. This has to be water, and this has to be island. And I think this has to be a 4-cell cage here, because it cannot go to here, right? So you can't have 6, 8, 9. So this has to be a 4-cell cage that adds up to 23, 24, or 25. We're not sure which. 1, 5, 6. Oh, 6 is here. This can't be 6. So this becomes a 4, 9 pair, which eliminates 4, 9 in the rest of the column. Therefore, this is 6. This is 9. None of these can be 9 here. These can't be 1 because of the 1 in the row. Can you ever have a 1 here? 1, 4, and 6 adds up to 11. To add up to 23, you'd have to have 12. So no, this can't be 1. This is 7, which makes this a 1. So this can't be 1. These can't be 1 either. We have 4 and 7. That's 11. Can you have a 2 here? I don't think so, right? If you have a 2 here, that's 13, and therefore that digit would have to be 10 to add up to 23 at least. So this can't be 2. This is 6, which means 6 cannot be here. This can't be 6. This is a 1, which makes this 5, which makes that 6. This 1 eliminates 1 here, and 6 eliminates 6 here, so this is 2, which means this can't be 2. Where's the 2 in column? Well, this 1 eliminates 1 here, so this is 4, this is 1. This 1 and 4 eliminates 1 and 4 here. It's 6. That 4 and 6 eliminates 4 and 6 here, so it's 7. This has to be 2. This 7 eliminates 7 here, so it's 8 and 7. This 7 here eliminates 7 here, so it's 9 and 7, which makes this not 7, so it's 9 and 7 there. This can't be 6 either of these places. This 6 eliminates 6 here, so this is 5, which makes that 6. This 5 eliminates that 5, so this is 4. This can't be 4, 5. It's a 6. Can't be 4, 6, so this is 5. This 4 eliminates 4 here. It's 9, 4. This 4 eliminates 4 here. It's 1 and 4. We have 1 and 9 remaining here. This is 9, and this is 1. That leaves these as 5, which has to be here, and 8. Wow, that was an impressive solve. So much so, the lieutenant thinks that you might have what it takes to tackle the most mind-bending case that has ever happened in our city. A case that remains unsolved after 40 years. This was fairly tough. 4 and 6 added up to 10. 7, 8 added up to 15, so it's 25. So this is just a suspect. So this is a suspect cage here. That was definitely a puzzle. Lots of implications going throughout here. I almost miscalculated this. Since this was 11, this had to be 8 and 10, which made this 44, which meant the 2 was in and the 1 was excluded. So I was like, wait, the 2 has to be out, but then we have the 3, 5. Yeah, it was just all... My mind was going a little bit at that time. Pretty crazy. Pretty interesting, too, how everything interacted. Lots of geometric logic, lots of just calculating logic, lots of the digits signifying their island size logic, which led to geometric logic, which led to other things. I never felt completely stuck, though. It always felt like there was always something that I could find further along. So, I don't know. Fun puzzle. Fun puzzle. And I hope you had a fun time watching this solve. And I'll see you next time on Frank Puzzles. Take care.